Good morning class 8th. Yesterday we have discussed human ear, structure of the human ear and function of the human ear. Student, today we will discuss the next topic, characteristics of a sound wave. Student, we can describe a sound wave by its frequency, time period, amplitude, pitch and loudness of the sound. You can see here speed of the sound. So student, now sound wave can be described by its frequency, amplitude and speed. So student, if we talk about the sound can be graphically represented as a wave. There is a change in the density and the pressure as sound moves in a medium. And we have discussed about the compression and rarefaction. So compression means high pressure where the particles are crowded. You can see here this picture. And the reason of the high pressure, this is the reason of the high pressure and the density, and represented by the upper portion of the curve. You can see this crest, upper portion, you can see this. And the rarefaction are the reason of the low pressure and the density where the particles are spread out and are represented the lower portion of the curve called torr. The distance between the two compression and the torr, the rarefaction is called the wavelength, and it is represented by the lambda. This is called lambda. You can see this lambda. This is the wavelength, and the distance between the two compression. You can see this is the compression upper surface. You can see this, the distance between the two compression is called wavelength, and it is represented by the lambda. And the Greek letter, this is the lambda. And what is the wavelength? What is the unit of the wavelength? Meter. So student, today we will discuss frequency, amplitude and speed. Okay. Now student, first we will discuss the frequency of the sound wave. So student, when the sound is propagated through a medium, what will happen? When sound is propagated, when sound is travel through a medium, what will happen? The density of the medium oscillate between a maximum value and minimum value, to and from, sometime maximum, some minimum. The change in the density of the medium from a maximum value to a minimum value again to maximum value is one oscillation. So first of all, you should know what is the frequency. What is the frequency? So what do you mean by the frequency? Frequency, the number of the oscillation per unit time. The number of the oscillation made by a vibrating body in 1 second is defined as a frequency. So student, you can take example of a drum. Understand? So suppose you are beating a drum. So how many times you are beating the drum per unit time? How many times you are beating the drum per unit time is called frequency of your beating the drum. Listen carefully. When you are beat the drum, so how many times you beat the drum in per unit time, that is called as frequency. So you know that when the sound is propagated through a medium, the density of the medium oscillate between the maximum value and the minimum, crowded, compression and rarefaction. Understand what I am saying? And student, the unit of the frequency is hertz, Hz. So The number of the oscillation made by a vibrating body in 1 second is defined as the frequency. And student, it is also explained with a term called pitch. There is also a one point is a pitch. Higher the frequency of the vibrating body, higher will be its pitch. If there is large frequency, higher the pitch. If there is a low frequency, it is the low the pitch. And the different frequency of the sound produced in musical instrument are nothing but the different notes. Frequencies measured in hertz named after the scientist Heinrich Hertz. Higher the pitch, higher the frequency, or you can say that higher the frequency or higher the pitch. Okay. So now student, we will discuss the time period of the sound wave. Listen student, time period of the sound wave, time taken, the change in the density of the medium from a maximum value to a minimum value again to a maximum value is the time period of the sound wave. Time period. So listen carefully. How can you find out the time period? Time period is the time taken from one complete oscillation to take place. When the one oscillation complete, the time taken, that is called time period. So time period is the time taken for the one complete oscillation to take place. One oscillation करने के लिए जितने टाइम की जरूरत है, that is called time period of the sound wave. So time taken, it means you can take example of when you beating the drum. So when you complete the one oscillation in the how much time you will take, this is the time period of the sound wave. And student, the time taken for one complete oscillation in density of that medium is called time period, and it is represented by the capital T. SI unit of the time is second. So frequency, what is the relationship between the frequency and time? So student, listen carefully. Always the frequency and the time are the reciprocal of each other. So frequency and time period are related as V is equal to 1 upon T. ठीक है, V, you can say this, T is equal to V or V is equal to 1 upon T. This is the frequency, this is the time. So student, listen carefully. If we talk about, so we can say that the time taken for one complete oscillation in the density of the medium is called time period of the sound wave, and it is represented by the symbol capital T. Okay, so first of all you can take example of the violin and flute may both be played at the same time in an orchestra. Violin also and flute also, both sound travel through the same medium, that is air, and arrive and are here at the same time, but sound travel at the same speed irrespective of the source. But one is the violin and one is the flute, so these are the different sources, so the sound we receive are different. So this is due to the different characteristics, that is called pitch. Pitch is the one of the characteristics. So first of all you know what is the time period and what is the frequency. So what do you mean by the frequency? Number of the oscillation per unit time, it is called frequency. And time period, the time period is a time taken for one complete oscillation in the density of the medium, that is called time period. Okay, now student, we will discuss the amplitude. Amplitude means the distance of the maximum displacement of the particle, the medium, from its mean position. So if we talk about student amplitude, so amplitude student, the magnitude means numerical value of the maximum disturbance in the medium or either side of the mean value, that is called amplitude. and the amplitude of the sound wave is the height of the crest or the throat, and it is represented by the capital A. So student, the term amplitude is represented by the distance of the maximum displacement, जितनी maximum displacement की अपनी mean position से, अपनी starting position से. So you can relate it the loudness. There is the another quantity, loudness and the pitch, and this loudness is related to the amplitude of the sound wave. If there is a more amplitude, it means larger the maximum the displacement, so louder is the sound. So first of all, when, for example, when you strike the string of a guitar lightly, we produce a sound. When you strike the string of the guitar very lightly, what will happen? So you produce the sound and you can hear the sound lightly. If the same guitar string struck with a great amplitude, what will happen? The loudness of the sound here increase. Understand? So if you create the distance of the maximum displacement larger, so the loudness also will be increased. If you string the guitar lightly, we produce a sound, and if the same guitar string is struck with a great amplitude, the loudness of the sound heard increases. So these are related with each other. And the pitch depend on the frequency of the vibration. If the frequency is high, the sound has high pitch. If the frequency is low, the sound has low pitch. You can see diagram. Okay. So the waves are traveling at about the same speed. So this is the number of the each wave that will reach the ear in 100th second. Short wavelength means lot of waves, high frequency, high sound. So there is a simple. So first of all, you student, you should read this: frequency, time period, and amplitude, and the pitch and loudness of the sound. And the loudness of the sound depends on the amplitude. If the amplitude is bigger, the sound is also loud. If the amplitude is smaller, then sound is soft. Okay. Loudness of the sound depends on the amplitude. What do you mean by the amplitude? The distance, the maximum displacement of the particles of the medium from its mean position. Okay. Larger the amplitude. If the amplitude is bigger, the sound is loud, and if the amplitude is smaller, the sound is soft. You can say this. Okay. So I hope you understand, students. So first of all, you read this. Okay, students. Bye. Take care.